So these lectures is of course a continuation in a way of the first one. But here what I want to do is really focus on oriented object programming. So far I've seen a lot of objects technically, which is dictionary, list, tuple, and set, which are technically all objects. But here we're going to clearly describe what is an object, what is a class, what is an instance, what is an attribute, and so on. So I will put the naming. And what I will also do is basically teach you a bit what is object-oriented programming. So that's the first part, teaching what is object programming, a lot of definitions. I will spend a lot of time on data class. So it's a nice way to structure the code, basically. And then class inheritance, and actually this I will not cover too much anyway. Okay, so typically the style of programations is typically procedural. So what is a procedural language or way to do your code is you basically describe step by step the procedures. So you say, here's the beginning of my code, I'm doing that, I'm doing that, I'm doing that, I'm doing that. You are basically following a flow, I would say. Object-oriented programming is that your main structure is the object itself. So what is the structure of data that you are going to handle? What is your problem in terms of data? And how you're going to change those data? What are the functions and methods that are going to apply on the data? So you are much more focusing on what is the data structure, what is the structure of your data, what is your input in a way, and how this you're going to handle those. So it's slightly different. And the border is not always fully clear, I would say. So let me give you a procedural example. So that is actually an actual example I've did recently. I mean, except that the questions are just for the fun here. You can read them if you want to have fun. I guess it's not very funny, but okay. So a couple of months ago, I had to create a trivia test actually when you go to the cluster. So for those who have access to the Manback cluster, now if you are a newcomer, when you arrive, you have to pass some tests to check that you know what is a module, you know what is Slurm, and basically I mean, everyone here should know that now. But basically we have some tests, and I've done that in Python. And that's a bit, I started actually with a code like this. So basically not that much structures, I would say, and then I've move that code to object-oriented programming because it was much more useful at the end of the day. So that is a bit the story I'm going to do in these lectures, starting with a very simple code, very readable, I would say, which has basically a score. This is how many score you have. This defines the questions. I'm printing the question on screen and ask you what is the correct answer. If your answer is 1, then I give you a point, then I pass to the next questions, and then at the end of the day, I print the score. So very, very simple stuff. Of course, here we don't care about the questions. They are completely random questions, obviously. Very, very simple example. So when you see this code, I would say, what is the issue you think there is this code? It's a nice code in a way, but there's also a lot of issue in that code. So spaghetti code. I would not say too much spaghetti code because it's quite linear in a way. So for me, it's quite readable. When you read the code, it's quite readable, I would say. So spaghetti code, I would say it's reasonable as well. Same code is repeated. That I agree. In this case, it's also quite limited in a way because in a way the code doesn't do that much so far. So I'm repeating a bit here. I'm repeating a bit here. So I have some repetitions. I can do better, obviously. It's not too bad. It's not critically bad at this stage, but it will be as soon as I wanted to do more stuff. No more ID. I don't see anyone typing, so I guess not. So one thing I don't like in this code myself is, I mean, there are multiple stuff. One thing I don't like in terms of features is that when I print these questions, it's not clear for the user if they need to answer the full stuff or just a number. And that means if they type high performance computing completely, they will not receive the point because No, the answer is just 1. If they put 1 in the space, they also not get the point. So there's a lot of issue there. So that means our need in terms of features in itself, if not the code is bad, but it's just that if I want to have that more solid in a way, I need to put a lot of logic here. And that means I need to repeat my logic. And that's going back to one of the points, is that I nearly repetitions, but now if I want really something more robust, I will have a lot of repetition. The second thing I don't like as programmer, I would say here, is that the formatting of the questions, the fact that it's 1 dot, 2 dot, and then a space, then X space here at the beginning and stuff like that, all that is done by hand. That means if at some point I want to basically say, oh, there's too much space here, I want to remove them, I need to change all the questions, which is annoying as well. So that is, for me, the 2 main issues in a way. I have some repetitions. I said it's not too critical. I have the formatting of the questions, and then this code is a bit too limited in a way to be put in production for a lot of people. So we create a lot of issues. So typically, especially if you have a lot of repetitions, or if you want to do more that will create a lot of repetitions, the next step is to create a functions. So in this case, I create a functions ask that will take 2 inputs. The first is a questions, which is a string, which is, I'm going back here, it's only the first line. What is the meaning of HPC? That's what I mean by the questions. And after that, answers is the list of answers. So in this case, it's a list of length 4 because they have 4 possibilities, 1, 2, 3, 4. And then I'm adding, in a way, 2 features inside these functions. The first one is an infinite loop that is checking that the user enter 1, 2, 3, or 4. If enter anything else, it will say retry and valid answers 1, 2, 3, and 4. So that allow me that if you print the full stuff or anything and fail safe, I'm not removing point for nothing, you just have to retry. And then the second thing I've updated, and that's you can read those, but it doesn't matter too much. It's basically this is used for formatting the text. So I'm adding the 1 dots exactly in the previous answer, putting the space, all those kind of stuff in this part. It's not the point of these sessions. If you want to read and check that I've done that correctly, it's fine. It's not the main stuff. So what I did is I created functions, and that of course helped quite a lot. So now if I'm looking at the main code, I take this if main and stuff like that. And now my main code is still store equals 0. And then I'm calling my functions, taking the functions, the list of answer, and then doing directly equal 1, and then score plus equal 1. So now I need to check if I did that correctly, that I'm returning an integer because I put an integer here. So that's why here I put an integer now compared to the first code, what is string, and the same for the second one. So this is a bit better in a way because I have new features basically, and my code is still readable, I would say. But I'm still in my repetitions, I'm updating my score, and the data are within the code itself, so that's a bit annoying. Okay. So what I'm going to do is to create a real data structures. What I mean data structures is an object that I will call questions, which will contain 3 informations. What is the questions I'm asking? And then that's the questions here. What are all the possible answers? And what is the correct answer here? So it's an object which contains 3 informations. You have seen in the C, we have the structure construct. You have seen the same in Fortran. If I don't remember what they call the structure in Fortran. I don't remember. You've seen those kind of constructs quite often. So this is the definitions. You have class. So in Python, the data structure itself is called a class. And then you have the init, and self is basically where you store the information. So self.questions, you define here a space with these questions, and you assign the value which pass here, self.answers, and self.correct. Init is what we call technically a constructor. So you create the object, here. And here we basically set up all the values here. So this sounds probably a bit abstract. So let's go to Visual Studio Code to play a bit with this. So here it is. That's exactly the same line as you've seen on the slide. I'm creating a class which is named username questions, and to initialize, I need to pass actually 3 variables. So we'll come back and set it later. But set is just a container saying that's where you store your variables. So I already, let me rerun it to be sure that there's no issue. And then I can do Q equal questions. So that is the part will be stored inside the questions part. Put a point mark, this is quite fun. Let's put some answers. And then let's put the value for the correct. I don't know why I like to do this. And then I say, I will put the index in this case. So let's say 0. Oh, that's not the one I want. Yeah, it's here. So now that I have this, I can add a code, and I can print q.questions, and it will return me exactly these strings. I can obviously do print.answers, so that's the same. It return me all the answers, and I can obviously print q.correct as well. So those are not read-only, so I can change them as well. So at any state, at any time, I can do q. Let's say correct equal 1. You know, if I'm printing it, let me print it here. It will return 1. So I can change any of those data at any time. So here I just have a data structure. So instead of having, in a way, 3 inputs per question, which is what is the questions, what are all the answers, and what is the correct answers, now I have one object, one place, which contains basically those 3 informations. Yes, you can also put type int, it doesn't matter. So in terms of naming, questions is the name of the class. So question is a class, which is basically a template, if you want to see it like that, which is saying basically what are the content inside it, which means in this case, it contains 3 informations, the questions, all the answers, and what is the correct answers. When you say Q1 equal questions, Q1 will be what we call an object. So that will be an actual member of the class, which is like, let's say the human are part of the class mammals, and then we are actually one element. That will be the same here. That's what we call an object. We also create an instance, so here an instance of the class questions. So object and instance, in my view, are extremely synonymous. I'm pretty sure if you call an actual computer scientist, they will say object and instance refer to slightly different stuff. From my point of view, they are basically the same. When you say q.correct, this is what we call an attribute of the object or the class. So that's taking part of the memory space which is associated to q, and that's specific to each object. Obviously, you can have multiple objects. And self, that's represented inside the class the current object, actually. So let me say that. So here I have Q, I can have Q1 and I can have Q2, which are, they all have their own memory, obviously. So I can do this. And then let's put a stupid. No, correct equal 3. Why correct equal 3? Because I'd say I pass the index, so this index 0, 1, 2, and 3. So you can have as many basically objects for a given class, basically, which all have their own questions, all possible answers, and all correct value. So not things too surprising, I would say. So just to be sure, so I put the sentences here, and then basically a name is a set of elements with the same structures. The 2 is an element of that set. So basically where 1 and 2 can be replaced. So either 1 is class to an object, 1 is class to its instance, 1 is object to the second class, and so on and so on. So yes, that's the 2 object and instance, at least to my point of view, are completely synonymous. So both are correct answers, and the first one is with the class. So that's perfect. So now they've created my class, and therefore all the object of class questions. I need to change slightly my functions. So that was the functions I was using before. So I was passing the questions and all possible answers, and then I was doing all this blah blah. So now I can update it, and instead of passing 2 informations, I will pass 1 object, and then in order to not change at all this, I just have to redefine what is questions. This 1 questions of questions, and what is the valid answer is 1 questions of answers. So obviously in practice, I typically especially here the function is not too long, so I'm typically changing it a bit so that I don't have those alias here at the top. But that's really show you, but basically I just change the stuff. What is nice now is that I pass 1 full object, and I know that I will never have a mismatch between the questions and the answers. Those are really tied together now, and I might not put the answer of questions 2 with the questions 1, for example. That is the nice point here. Okay, so now my code, I would say it's a bit better. I first define all my questions. So I have now even a list of questions. I'm defining the first questions, then all the blah blah. Define also what is the correct value. Then the same for the second questions, and then I put all the questions in that list. And then for my running my code, I'm defining my score. I'm looping over all questions. I'm asking the questions for each. I'm checking they return the correct value, updating the score if it is the case. Otherwise, I print no, the correct answer was blah, and then at the end I print the score. So quite nice. Separation between what are the data and what is the code itself, and a quite readable code as well, obviously. So other questions. So what will be printed? Okay, this is change. Like previously, could like me to put some int. So I have a function which is change correct, which gets a questions and a new correct answer. Then change my questions dot correct equal new correct, and the question is if I print. So I create an object with stupid input here, saying that the correct answer is 1. So I'm changing correct of this object to 3. Is it going to print 1 or is it going to print 3? Yes, so that's good. So indeed, it's going to be print 3. So I'm just reassigning an element of my questions. My question is pointing to a place in memory. I'm changing basically inside that place of memory the value of correct. So that is going to be propagated after the functions. So that's extremely important to know, obviously, to be careful that if I put here my questions equal my questions, that will not be changed, exactly like we've seen this morning. But like this is going to change directly the memory, so no problem here. It's going to be used. It can be a problem, obviously, depending on what you want to do. Okay, so this will just set it. So now I'm going a bit more advanced. That's something I'm not using myself that much. The main reason is that I'm typically using, I need to be retrocompatible quite often up to Python 2.7, and that was not there in Python 2.7 yet, which is dataclass. So what is the issue with if I'm putting this code, yeah. What is the issue with this code? There are multiple ones actually. It's just that you are repeating yourself quite a lot. You see, in the init, you pass 3 names, questions, answer, and correct. And then you put questions again here, answer again here, correct again here, correct again here. So basically, you kind of repeating yourself, and you will have that type of element a lot of time. So this will happen a lot of time, that you basically have a data structures, and then you will always have the same structures basically here. So data class will allow you to avoid those repetitions. On top of that, in this case, so let's go to here. If I'm doing print Q1, wait, here it's yes. You have the answer here. You have this main.questions object at which is an address, obviously. That is not very useful in a way. So if you want to have a nice print statement, you need to update the question. So I'm going to do it once. That's something that typically you do for all the data structures that you use. It will be __ string. You just pass the object itself. And then you typically print something like questions. And then you put questions equal self.questions. If I'm doing it like this, I need to put a f string, comma, answers equal self.answers, put a s, and then correct equal self.correct. Yes, I'm doing the demo. So now if I'm doing this, okay, yes. It's not print here, but it's return, sorry. Still not. Why not? No, I need to be on this, I guess. Yes, no, I did. Yes. So yes, your questions?
It was return instead of print.
Oh, okay. So thanks. So thanks. So then, and then typically here we like to have a close parenthesis, but that's okay. So typically, when I define a data structures, I need to define the init, which contains a lot of repetitions. And I typically at least want to have the print statement to be nice as well. So I need to define this __ string here, which contains again a lot of repetition. So data class is a nice way to do that completely automatically for me. The syntax is what it is in a way. So let's go back to data structures. Here, you first have to import data classes. From data classes, import data class. And then you have a, before your questions, you do add data class, forget for the moment frozen equal true. And then you don't do any inits. You just saying inside the main questions, the type in is not needed. Answers, you can also say that it's a list of string. Again, it's technically not needed. This is actually not needed as well. The list you want to, by default, is an empty list. And then correct, you can also say that's an integer, not needed as well. And you can assign the default value as well, actually. And like this, data class will do everything automatically for you. So it will define what is _init, what is _string, also the _ presentations, also the equality between objects, and probably other stuff as well, actually. So it's going to define you a lot of stuff so that your class, your data structure is well organized without you to have to write a lot of lines of code, which are quite repetitive at the end of the day. This makes the code a bit more opaque. I mean, at least for beginners, so you need to know what data class is doing. But that's going to save you a lot of time. As I said, I'm not using that yet, but I'm really planning to use it because it's very, very powerful. On top of that, you have access to advanced features like this one, frozen equal true, and that's basically make your full object read-only. So that's if you want to try, I don't know if I put an example here. So if you want to change the same functions like change correct, you will crash now with a frozen instance error that you cannot change the value. As usual, having object in read-only has advantages because you are sure that no one is going to change your object. That means also you cannot change your object yourself, so it's a trade-off for this. In the print statement, I will say. So from now on, I will typically use this data class because it's allowed to not have to have a lot of print statements and a lot of stuff. I can just show you it once, I guess, at least. So these are the questions. So I will use the import with this at data class in top of the class functions. So just for the naming, this is a Python, normal Python syntax for decorators. So that's allow you basically to change a bit the behavior of the object after. That's the only thing you need to know. If you need to create your own decorators, that's quite complex, to be honest. And I always have to read the details tutorial online to how to do it because it's not that simple. But that's extremely powerful in a way. So that's allow you to change how the next element behave actually. So very powerful. But to create yourself, it's really difficult. And then you only define this. Why it doesn't like it? It has defining it. So now if I'm going back to this, so I'm predefining my two objects, you see that I have now a nice printing where I didn't define print myself, just coming automatically from data class. That saves me a lot of time of typing this. And in this case, I put frozen equal true. So if I use the where I put it, the change correct, let me try this one. It will crash with a frozen instance because I'm trying to change something which is read-only, so it's going to crash. So what is the main interest of data class for you, basically? Pure typing, that's number one. Easier instantiations. Yes. Yes, perfect, yes. So pure typing, of course, the main one. Also, I would say you have access also to advanced features like the fact that it's read-only. If you have to write that by yourself, it's certainly possible, but it's more difficult. Like you have it as well. You will also have another advanced features. I never use it myself, which is slots. So that change the way the class behaves, so that you have much more efficient memory and much more efficient speeds, but we have a bit less flexibility. So that's something I'm planning at some point to test, but that's also available for free in data class. So just if the slots equals true, and then all the things behind the door in a way, what's happening inside Python will change, and then you will have code which is faster and use less memory. In my case, sometimes memory is an issue, so I would like to test. But now I know there's less features on when you do that, so I will see. So perfect. So now for the moment, I always use the name data class. So we have a data class with data structures. And for me, a data structure is not really a class. So for me, a class is a data structures with functions. So in this case, I have a data structure, so it only contains data so far. Technically, it contains a bit more because data class is defining functions for me, like the function string. But okay, so now I'm going to put ask as the questions as the functions from within my class. So what I'm going to do is just doing this. So actually not that much exchange. The first thing that has changed is the indentations. So now the def doesn't start at the beginning of at the first column, but actually at the, I guess, fifth column, exactly like all those. So now I have my questions that belong inside the class. I also changed the keyword actually. So before I was just writing one question, so now I replace all the one questions by self. And the content of the functions, except that everything is indented, again by 4 space more, otherwise it's the same functions. You cannot read it, it doesn't matter anyway what's the detail of the functions here. Yes, no. Yeah, and I would say we have a gain in clarity because in the previous case, you were assuming that your data structure, your function ask, assuming that the object that you pass has the questions defined, has the answers defined, and has correct. Mark is not correct, I was not using it in that function. So now it's clear that these are functions that need to receive an object's question. Okay. So here's the next questions. I'm going to go back to see. So what is the self? So this is the second time we see self. We are seeing self in the init. You're seeing self again in these functions ask. So is it a reference to the current instance of the class, a restricted Python keyword, a normal variable which is assigned to the reference of the object x when the function is called via x.fct? What a long line. So yeah, I guess I have all the answers. So a reference to the current instance of the class, that's correct. It's not a restricted Python keyword, so you can use self for whatever you want as variables. Of course, don't do that. So it's not because you are allowed to doing it that it makes sense to doing it. If you use self for something else than the current object in the class, you will confuse everyone who's reading your code, including yourself in 5 years from now. So don't do it, but it's technically not a restricted Python keyword. And it is technically a correct definition as well. It's a normal variables in a way, which will be assigned to the reference to the object x, when it's called like x.functions. So this is also actually also a correct statement actually. You can have, of course, as many functions as you want. So in this case, I define inside my class, so this inside the class questions, I define a new function which is print correct, which is basically printing the correct answer was blah blah blah. And inside my main code, if I was ask q equal correct, when I'm using the class, now I'm changing this to q.ask. That's just changing the syntax here. So I'm asking the functions ask to just associate to the class of this object. And then here as well, instead of the printing, I'm now using these functions q.print correct. And here I put in the prefix no. Having this a bit modular. But it's really the difference. If you do ask blah blah, you ask the functions, which is the normal. Q.ask, you ask the functions associated to the object q, which is a bit like the attribute q.answers, q.correct. The fact is the functions now as a parenthesis that you call the functions per se. Okay. So one thing I like a lot, and if I'm putting my example with the questions here, is that you can do additions, multiplication between objects. And then myself I'm a physicist, so during my physics, it's quite useful to define the sum of two objects, the multiplications of the object, and just write object A times object B, that's returned object C. That's very practical, meaningful in a lot of cases. Of course, for questions, that doesn't make any sense to sum questions or to multiply questions. So I'm changing the example, and I'm doing an example with color, which contains red, green, and blue. The default is 0 for all of them, using the data class, so I don't need to define the init, the string, and stuff like that. Everything is done thanks to this keyword. I didn't put the frozen equal true, so I can change my value. And then here I'm defining the sum of two objects between self and other. Type int again, doesn't matter too much. And then I'm just doing the average of the two colors. So I'm just mixing two painting basically together, mixing them together. So I'm taking the average and I'm returning a new object with those three values. And then I can do blue equal color, red equal color. Now I can print blue plus red. And that is, I think, extremely powerful to be able to define additions, multiplications, subtractions, divisions, if those make sense, of course, for the objects you are using them. I like it a lot. So I'm going to give you 5 minutes to create 3-4 lines of code to basically create a vector. I guess everyone knows what a vector is. So you can put fixed length like 3 elements you don't need to have abstract versions, obviously. And this defines the multiplications of two vectors. The normal vector, if you don't know, it's the first element times the first element plus the second element times the second element, and so on. But again, that's not the main point. We just create a 5 lines of code basically doing this. So this is an example. You can implement that in many different ways, obviously. So I take it a very simple way. So I'm using this add data class, define class vector. Type that data class, I just define 3 inputs x, y, and z. It's all default value to 0. So exactly a bit like the color example in a way. And then I define my multiplications. So this double underscore multiplications between two objects. And then I'm returning basically the product here. And then, okay, some example here. So let's put a very simple example here, so that this returns 0 because this orthogonal, obviously, and this is 2, for example, which will return 2, obviously, yes. So 5 lines of code. Okay, any questions on that? Okay, so the last thing I want, let's move this. Last thing I like also about class is what we call inheritance. So in this case, I have, going back to my previous example, I'm going to define a new class, which is, this name is questions status, which is question with the status actually, and which is going to inherit from questions. So what this means is that everything which is defined in questions, so that means all the attributes are defined, so questions, answers, and correct, but also all the functions that have been defined in questions. So far, the questions asked and the questions print correct, for example, will be available in this class, question status, without me having to rewrite all the stuff. So it has the same data structures, at least at the start go, and it has all the same functions available, without having me to write any line except this. Now I can, so far it's there. I mean, if I only write this, I have basically two classes which are exactly the same with a different name. So no much interest in a way. I mean, no interest at all. What is interesting is now I can overwrite or add functionalities. So I can add this question status and add new functions, or I can override the init functions completely. So that means now I can change the behavior of any functions in this class, but keep all the other functions exactly the same. I can also do what I call collaborations. So here I'm overwriting the functions init, and actually the first things I'm doing it is calling the same functions, I mean questions.init. So I'm going back to the original functions and saying, do actually everything as standard for the questions itself. And what I'm doing it is actually adding two informations, which is the number of times the user has tried the functions and the number of times he succeeded. So I'm basically extending my questions with more informations, but now I have the question itself, which doesn't have anything like that. I can still use it. And now I have a question with status, which has those informations more. And I can basically extend like this a new features, but still not having to rewrite the full stuff. What is the print? What is the blah blah? What is the ask functions? All of those will be the same, but I can basically add new functionality around, basically before calling the function, after, and stuff like that. So I can change my structures quite a lot and extend basically my code and have more and more concrete implementations in a way. So this is something that I'm using quite a lot. I have a base object which doesn't have that much features in itself, and then I have much more advanced object which do something more specific, but contains all the same structure that a lot of other objects, and all things which is in common will be in the questions part. Everything which is more specific to one object in particular will be in the concrete, I would say, concrete implementation. So that's allow me to have different abstractions layer without having to repeat myself all the time. And this will be the last question because it's 30, then I will finish here. So if a child class doesn't define a functions, and I'm calling a functions which is not defined in question status, like in the previous slide, I didn't define in questions, what's going to happen? And yes, so that's the mother function. So if in question status I don't define something, all the questions, I mean, all the logic will be taken by the mother. And that's extremely powerful. In Python, I will skip that very quickly. You can also have multiple inheritance. So you can inherit from more than one class. And that's quite nicely handled in Python. In a lot of other language, it's forbidden, or it's extremely complex, like in C++, which is they basically tell you not to using it, so complex. In Python, it's really well handled, actually. And then I will skip this. So that's basically it for today. One main message to me is that even if you don't like object-oriented programming, you need to structure your data. Your data will be well defined. That is all the inputs. That's how you organize your data. That's the main stuff. And therefore, I would say that using data classes is kind of a must. It's really useful. For naming a class is a data structures with functions. I would say it's extremely powerful. The inheritance, I mean, I'm using that all the time, and it's really nice. You need to force yourself at the beginning on one example. Let me try to use object. Let me try to use inheritance. It's not natural the first time, but after a couple of tries, it's still a really wonderful way to program.